Welcome to our new video. Today we are discussing about 400/440 micron fiber optic patch cords. The 400 micron is the core diameter of the fiber and the 440 micron is the cladding diameter of the fiber. The core is made up of silica and the cladding of this fiber is made up of fluorine doped silica. The numerical aperture of this fiber is 0.22. Now, coming to the application scenario of this fiber ranging from industrial to research. These fibers are mainly used for high power laser delivery, spectroscopy, certain sensing applications, as well as some medical diagnostics applications. These type of fibers have been used. These fibers you can see in two categories mainly. One is low OH absorption fibers and other is high OH absorption fibers. These low OH absorption fibers, the transparency wavelength is ranging from 400 nanometer to 2400 nanometer wavelength. Whereas the high OH absorption, whose transparency window is low compared to these low OH absorption fibers. The transparency window for high OH absorption fibers is 400 micron nanometer to 1200 nanometer. This is the wavelength scenario. Now coming to the DNC's fiber optic patch cord of 400/440. DNC makes this with a variety of connectors. One is FC to FC. So this is a 1.5 meter length patch cord. Both end is terminated with FC type connector. So we can make SMA type connector terminations with these patch cords, or any other desired connector the customer suggests, we can terminate that fibers and give as a product. Now another customization we have made with this category of fiber is one end is FC connector and other end is a ferrule. This makes this patch cord as a platform independent product. Why? Because in certain scenario you can see, suppose this end of the fiber is FC and this end is ferrule, as I said earlier. So suppose a system which is having a different type of connector. In that scenario, we can connect one end with this FC connector and the other end to a system which is a different connector with the help of a sleeve. So the interfacing makes easier. You have a system with SC interface. You cannot plug this FC type connector into that system. And in that scenario, we have to use a ferrule terminated structure. This ferrule along with a sleeve can easily interface any connector. That is the speciality. So as per customer requirement, we have made a product like this. Apart from that, DNC uses a product tag, which is a ID basically, which will be attached at both end of the connector. So this makes a normal user to identify the tip of each fiber. Here, each fiber optic patch cord is identified based on their ID, which is marked as red inside the picture, and the type of fiber, which is 400/440 micron, which is printed at the middle of each fiber optic patch cord. This enables a user to identify the type of fiber, the end of each fiber or the tip of each fiber among a bunch of fibers. This is the speciality we do with the patch cords. All type of patch cords we manufacture will have this ID as well as the fiber type. In this section, we are testing the end face of the fiber optic patch cord. Initially, the patch cord covered with the dust cap is removed. Now that tip of the patch cord is inserted on a microscope. Now the N phase is seen. The dark spots indicates the dust particles present at the tip of the fiber. This causes loss. So in order to clean, we use an IP solution and wipe it. It will clean the dust particles. Now the N phase is perfect and clean. The outer ring is the cladding and the inner white portion is the core. Now feed the light on the other end. You can see the light appears on the screen. Now this is a perfect N phase. So the loss will be minimum. For any patch cord, we used to test the N phase with this microscope as a part of quality checking. If you are interested more on our videos, please contact us. Thank you.